Okay, so we spent a couple days on line reflections. So we're sticking with reflections, but now we're going to do something called a point reflection. And it exists when a figure is built around a single point called the center of the figure or point of reflection. So where instead of reflecting into a line, which was more like a flip, now we're having every point look into a point. So if we just look at, even if we just look over here, this point is the center of reflection, and every point is being reflected into that. Every point of this triangle is being reflected into that. So that's going to be the idea behind today. Okay, so like I said in the previous slide, a point reflection is when every point of the figure is reflected into a point. So the origin in this example is the point of reflection. And if I just look at A, right, it's basically like counting slope boxes. To get to A prime, I'll just count down 3 over 1, down 3 over 1, and that gets me to A prime. If I would do the same thing for B, and I go down 2 over 1 and down 2 over 1, I get to B prime, which is the image. C, down 2 over 5, go down 2 over 5, and I get to C prime. You could also imagine if you connect a straight line between the point and the image point, okay, the origin would be the midpoint of it. So hopefully this makes sense. But take a notice of what's happening to the coordinates. 1, 4 became -1, -4. 1, 2 becomes -1, -2, and so on. Okay, so here's just another example. Again, take a look at what's happening to the coordinates. If we take a look at A, -4, 1, A prime is -4, is 4, -1. The same thing for B and B prime, C and C prime. So if you just take from those two examples, what happens is the sign of each coordinate changes. So xy becomes -x, -y. Again, you don't have to remember the rules for any of these transformations, but they're helpful. So I can take this point here, and if I'm reflecting into the origin, I literally just count boxes to the origin. So down to 1, 2, 3, 4, 5 over 6, down 2 over 6, 1, 2, 3, 4, 5, 6. And this would be my A prime. That's going to be 6, comma, -2. If I do the same thing for B, I go down 3 over 2, down 3 over 2. And this is my B prime. I'm going to just write A prime here. And that's 2, -3. And then C, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Sorry, I miscounted there for a second. That's my C prime. Okay, the coordinates are 4, -6. So there's always a quick way to count boxes, right? But if you want to remember the rules, okay, these are the rules. So a good reason for knowing what to do, like without the rules, knowing to count slope boxes, is this example right here. Because you're not always going to be reflecting around the origin. Oftentimes you will be, but sometimes it might be a random point. So the random point is here. Okay, it's -2, -2. That's not super important, but we have to count boxes because the rule won't work here. So I'm going to go 1, 2, 3, 4 down, 1, 2, 3, 4 over. So I'm going to go 1, 2, 3, 4 down, 1, 2, 3, 4 over. So my A prime is going to be here at 2, 1, 2, 3, 4, -6. Okay, and now I'm going to take B, and I have to go 1, 2, 3, 4, 5 down, no, not over, just 5 down. So I'm going to go 1, 2, 3, 4, 5 down, and that's my B prime, which is -2, -7. And then last but not least, C, 1, 2, 3, 4, 5, 6, 7, 8 over 2, down 1, 2, 3, 4, 5, 6, 7, 8 over 2. So I off the graph a bit, but that's okay. C prime, that's going to be 0, -11. And I'm going to connect like this. So the rule doesn't work here. So you have to know how to count boxes. All right, so on this slide is just a reflection review. So here are all the line reflections that we learned previously. And then today, this is, again, it's only the rule for the origin reflection. So if you wanted them all in one spot, this is the place. Again, you don't have to memorize any of these because there's a way to do it without learning the rules. Okay, so in all of these line reflection, length is preserved, but orientation is not. So what that means is that the distance of all of the sides are the same. So the size doesn't change. And that's also true for a point reflection. Everything stays the same as far as the size is concerned. But in a line reflection, orientation is not preserved, whereas in a point reflection, it is. And what that is, orientation, if I haven't spoken about it before, is the order of the lettering. So what that means is that if I have triangle A, B, C like this, when I read this, I go A, B, C around. That's counterclockwise. And when I do a line reflection, let's say there was a line here, this would be A prime, B prime, C prime. Now when I go A, B, C, I go clockwise. So the orientation is not the same. For the original, it was counterclockwise. And for the image, it was clockwise. So orientation is not preserved in a line reflection, but it is, if you go back and look at our examples, it is preserved in a point reflection. And this last slide just shows all of the properties that are preserved in each. Okay, so again, the only difference is that orientation. All of these things stay the same when you do a line reflection or a point reflection.